What's up, party people? I'm Steve, and today we're talking about easy, everyday cybernetics. But before I begin, I want you to think of some repetitive tasks, something you do frequently, something you don't want to do anymore. And then when we get to the more practical part of the talk, then maybe we can try automate some of those tasks away. So it's going to start with some theory. So cybernetics, it encompasses a bunch of things, but you can think of it the science and art, the understanding of understanding. So that's metacognition, thinking about thinking. The control of an automation's feedback loop, interaction in dynamic networks, and then the study of systems and processes that interact with themselves to generate themselves from themselves. It's a pretty highfalutin of saying you take input, the system generates an output, and then you feed that output back into the system as input. So cybernetics, the word comes from the Greek for Kubernetes, which means steersman or governor or captain. And this field aims to bridge the gap between organic and mechanical. The idea is that biological nervous systems and electronic circuits, they're governed by the same laws. And like many technological leaps, it started with World War II. There was a mathematician, Norbert Wiener, and he was trying to solve the problem of aiming anti-aircraft guns at moving targets. He realized that standard deterministic physics, it wasn't enough because the enemy pilot reacts. So the gunner fires at the enemy plane, and the enemy plane, they take evasive action to try dodge it. And then the gunner has to readjust his sights to try shoot the plane again. So Norbert Wiener, he realized the system is not linear, it's circular. The output, which is the shells fired, it affects the environment. That's the flight path that the pilot was on. And then that feeds back as new input. So the new position gunner has to aim at. So he called this circular causality or the feedback loop. Now, this idea, this field, it represents a big upgrade to our intellectual model of the world, because before this, science was about structure. We lived in what's called a Newtonian clockwork universe. To understand an organ or an engine, you took it apart. You looked at the pieces, and the assumption was cause led to effect in a straight line. It was a linear relationship. But cybernetics changed that to focus on behavior. You can't understand the system by taking it apart. You have to watch it run. And it proved that interactions are circular and not linear. And it shifted the fundamental question from what are the parts of the system to what's the purpose of the system. The term cybernetics hasn't really caught on. So we just call it AI or data science, but the mechanisms are the same. They're systems that are designed to reduce entropy and pursue goals within a chaotic environment. So the big idea is feedback and entropy. So the core of cybernetic theory is the concept of entropy and its negation. The second law of thermodynamics states that in a closed system, entropy, which is disorder, it tends to increase over time. So Wiener, he conceptualized of information as negative entropy. Information is the measure of order. It quantifies how much pattern or structure exists within the system. So information is negative entropy. And in a cybernetic system, it could be a single cell, it could be a whole human, it could be a machine. It's a local pocket of anti-entropy. It maintains a structure and internal stability against the chaotic pressures of the environment through the mechanisms of feedback. So you've got positive and negative feedback loops, but don't confuse it with positive and negative, that it's like good and bad. It's the same with positive and negative reinforcement. So you've got positive reinforcement, and it's about giving a reward, and negative reinforcement isn't about a punishment. It's more like maths. So positive reinforcement, you're adding stimulus. Negative reinforcement, you're subtracting, you're removing stimulus. That's probably where the confusion comes from, because normally we add rewards, positive, and we remove pain, negative. But it doesn't have to be a good thing to be positive reinforcement. So you can think of like internet trolls. An internet troll leaves a mean comment, you get mad and reply with your own mean comment. But actually, this is positive reinforcement because you added attention. Even though it was a mean reply, you added the stimulus the troll wanted. So the behavior wasn't punished, it was rewarded. So if you feed the trolls, the trolling increases, they're feasting. And for negative reinforcement, let's say a kid does well at school, and then the mom goes, you know, great job. You don't have to do chores this weekend. No chores. Now, some people think, hey, it's a reward, so it must be positive reinforcement. But no, wrong. It's negative reinforcement because you didn't add a prize, you subtracted a chore. So you took away something they didn't like. That's positive and negative reinforcement. I mean, look at positive and negative feedback loops. So in biology or engineering and other systems, it isn't about adding or removing stimulus. It's more about the direction. Positive feedback, it's about amplification. The system, it drives further away from where it started, and negative feedback loops are about balance. It corrects the system to bring it back to normal. So your oven element turning on and off to try and maintain a constant temperature, that's a negative feedback loop. Or the pupils of your eyes dilating, shrinking and growing, depending how much light there is, that's a negative feedback loop. Actually, a lot of the body's regulatory systems are negative feedback loops. And then for positive feedback loops, let's say you're in a video call, and then you say hello, and no one's wearing headphones. And then the other people in the call, their speakers, they just output what you said, then it feeds back into their microphone. And then it comes out of your speaker back into your microphone. And so you get that annoying echo, and then it quickly turns into that high-pitched screech. That screech is a positive feedback loop. It's not positive because I love the sound. It's positive because the output is feeding back into the input to create that runaway cycle. It amplifies the sound over and over until you have to mute the call. So negative feedback loops, they aim for stability. So they try to cancel out the change, the deviation to return to the balanced state. That's homeostasis if you did biology. And then positive feedback loops, they aim for amplification. They reinforce the changes to push the system towards an extreme or a runaway state. So yeah, that's the theory. So cybernetics, it aims to solve the paradox of how do you get smart behavior out of dumb parts. This is called teleological behavior. It usually means the ends justify the means. But in engineering, it means the output controls the input. So these systems, they don't follow a straight line. There's an end goal, and the system constantly corrects itself to try get to that end goal. We're going to talk about first order and second order cybernetics. So first order is an external view. The human's outside of the system. We treat the system as a separate object that runs on hard data, like the thermostat in the oven turning the element on and off. We observe it, but we're not a part of the feedback loop. And then second order cybernetics, that's the participant view, where the humans inside the system, they operate inside the system. The observer is an active part of the loop. The system can't function without the user's influence. Okay, that's the theory. Hope you got all of that. Now I'll do some history. So while Norbert Wiener was formalizing cybernetics at MIT, there was a more eccentric bunch of people in post-war Britain. They called themselves the Ratio Club. They hosted meetups in the basement of a hospital, almost like Fight Club. And some of the members, they include Alan Turing. There's the math guy. And then there was also W. Ross Ashby. He was a psychiatrist. William Gray Walter. He was a neurophysiologist. And then Gordon Pask. He was a polymath. He did chemistry, engineering, geology. I think he had a PhD in psychology. And then he made interactive cybernetic art installations. Then argue over stuff like whether the brain was a digital computer, which was Turing's view, or an analog balancing machine, which was Ashby's view. And this was a cross-functional team. It was biologists, engineers, philosophers, psychologists, all discussing the differences and similarities between biological and synthetic brains. And in this environment, they could synthesize cross-discipline ideas, and they laid a lot of the groundwork for modern AI. Now I'm going to show you some analog cybernetic systems starting from around the late 1940s. They're relatively simple machines. You'll notice that the intelligence and lifelike behavior doesn't necessarily need massive data sets or a lot of code. They can emerge just from the physical architecture of the feedback loops. So William Gray Walter, he built these tortoises called the Machina Speculatrix in 1948. He wanted to show complex behavior doesn't require a complex brain. He's trying to prove the principle of parsimony or Occam's razor, like the simplest solution is usually correct. Yeah, this was his argument against Alan Turing, because Alan Turing thought that the brain has to be this massive, super complex digital computer to work. And Walter believed that biology was efficient. He suspected that what looks like intelligence, it's often just reflexes interacting with a complex environment. So to demonstrate this, he built these tortoises that are called Elmer and Elsie, and they didn't have a CPU, they didn't have RAM or memory, there was no code. Their brains were just two vacuum tubes, and they appeared alive because they had a purpose. They would scan the environment to look for light and move towards it. If the light got too bright, they'd back away from it to avoid overheating. So that's the negative feedback loop. And then if they hit an obstacle, they trigger a bump reflex and they try and navigate around it. One day he had an idea to stick lights on the two turtles to see how they would interact. And unfortunately, there's no video of this. And he describes it as a mating dance. So they would react to each other's lights coming close together. And then when they got too close, they'd retreat in like a rhythmic dance. But unfortunately, because I guess the way this system operated, they would never actually meet. Sad turtles. It looks like social behavior, but it's not programmed. This is emergent behavior. This is complexity from simple feedback loops. Next, we've got Ross Ashby, and he built the homeostat. This is we called the ultra stable mind in 1948. He wanted to answer the question of how does the brain survive trauma without crashing. So he built this thing, the homeostat. The goal's pretty simple. It's got these needles that need to stay in the center in the state. So that would be the state of homeostasis. And then if the system becomes unstable, a switch would trigger, and then the system would randomly select new resistor values until it returns to a base state. So to prove this point, you would perform what you call brain surgery while the machine was running. They would swap out wires and flip switches and change the polarity. And then instead of blue screening, the homeostat would enter a state of chaos where the needles would start spinning wildly, and then the machine would start clicking and whirring while it randomly cycles through all the internal configurations until it eventually it would stumble upon a setup that compensated for the damage he did, and the needles would recenter, return to the base state. And it's not like the machine knew the wires were swapped, but it could sense that instability, and it explored its set of data until it found a solution. So this was the first hardware implementation of reinforcement learning. The system can survive in an unknown environment purely through trial and error. We've got Gordon Past's machines. I think Gordon Past developed conversation theory, so he was quite interested in like how do you chat to the robots. So he built this thing called the Music Color, and it's a light show that reacted to live music, like the Winamp visualizer. But he added a cybernetic twist that the machine could get bored. If the musician played the same riff too many times, the machine would just stop and the lights would cut out. And then to wake the machine up, the musician had to play something new, kind of like a call and response, dueling banjos type. So then the machine would basically train the human to be more spontaneous. And his other installation was Colloquy of Mobiles, where there's this huge room with these hanging robots. You've got the male robots in the middle. They've got a torch on them or a light emitter. And then the female robots have mirrors to catch light. And then when they connect, it would lock together. But it was an interactive art piece where humans in the room would be given torches and they could either help or interrupt the machine. So it was like a three-way social ecosystem. So the humans and machines could influence each other's behavior. Okay, so first two examples, that first order cybernetics, the humans are just observing, whereas this is interactive. So it's second order cybernetics. This one's my favorite. But here's the guy. Someone rebuilt this installation in 2018. And that's why there's modern pictures of it. There's a dude flashing the light to, I guess, block this robot. And this is my favorite, Stafford Beer and Project Cybersin. So Stafford Beer, he was a management consultant. He introduced cybernetics into business management. I think company was called Sigma, and he drove a Rolls Royce. And then in the early 1970s in socialist Chile, they attempted the most ambitious cybernetic experiment in history. It was called Project Cybersin, which is short for cybernetic synergy. And the goal was to run the entire economy of Chile on the national economy in real time, not through bureaucracy, but through a digital nervous system. So the network was called Cybernet, obviously, and they connected 500 factories using telex machines. They're like early fax machines that would send the daily production data to a central computer. The software that it ran was called Cyberstride, and it used this statistics to try detect anomalies in this information. And then crucially, if production dropped, the machine would alert the workers first, not the government, because it was designed for autonomy, and it would only escalate if the workers couldn't fix the problem. Project Cybersin. This is a communist utopia. Check out the control room. They designed it to look like the bridge of the Starship Enterprise. There's no papers or tables. There's these 7 fiberglass chairs and screens, and you control the whole economy just by pushing these buttons. Fully automated luxury space communism. I love it. Apparently, they even had ashtrays for your cigars and a little cup holder for your whiskey tumbler. You don't want to make a tool for tyranny. He wanted a tool for freedom. It was supposed to be a liberty machine. They even planned something called Project Cyberfolk. It was a system where citizens could use a dial to transmit their happiness levels to the government in real time. It's almost like, I don't know if you've watched The Orville, but there's an episode of The Orville where they go to a planet where if you get enough downvotes, they'll send you to re-education camps if you get enough hate online. So yeah, the socialists have some wacky ideas. And anyways, the dream died tragically or comically. It was definitely ironically in the 1973 coup in Chile, where the right-wing dictator Pinochet's soldiers had just smashed all the screens and destroyed the network. And that was the end of the socialist internet. So moving on swiftly to some old school digital cybernetic systems, we've got Vannevar Bush. He came up with the MEMX in 1945. He thought the problem wasn't so much in creating knowledge, but in finding it. So he proposed the MEMX. It's a desk that stores a whole bunch of documents. He never built a thing, it's just theoretical, but it stored a whole bunch of documents, not alphabetically, but by association. So he argued that the human mind works with trails, not categories, and it would allow users to link one document directly to another. So he effectively invented hyperlinks 50 years before the World Wide Web existed. Then we've got CJ Leclerc, and he came up with man-computer symbiosis. He didn't want the computer to be like super calculator. He wanted to be a partner, collaborator. He wants a friendly computer that would handle the calculations, the routine data, the math, and then the human provides the goals and creativity, which leads us nicely into modern cybernetics. Now, the 2025 and generative AI, cybernetics it's not just a theory. It's a massive stock market bubble waiting to burst, or it's the new operating system the whole world's going to run on. So how LLMs work is first you start with training. So you give the LLM massive amounts of content, every book, every article, every website we can find. And we break that content down into tokens, which are chunks of text. And then it looks for patterns. It learns that king usually follows lion. It learns that there's a mathematical correlation between love and heart and pain. And then next, what you do is you take those mathematical correlations and you deduce the probability. So when you ask the model a question, it's not thinking about the answer. It's calculating the odds of what token comes next. So if you type the sky is, the model calculates blue 90%, dark 5%, green 1%. It rolls a dice, and then it selects the token based on those odds. And then finally, the loop, this is the cybernetic part, where it outputs that token, then it feeds that back into itself as a new input to guess the next token. And it does that over and over thousands of times a second until you come up with the full sentence or whatever it outputs. And then the next important cybernetic loop is RLHF, or reinforcement learning from human feedback. This is a specific loop that turned the raw, wild, crazy ChatGPT-3 we all know and love into the useful ChatGPT we use today. And most of the AI or most of the LLMs are trained with this. So there's three components to this loop. You've got the LLM that generates high entropy output, so variety disorder. You've got a reward model that judges that output based on a score, and then feedback. The system updates its internal weights so that the next time you ask it, it will score higher. Now, critically, the reward model is trained by humans. Humans act as the captain. The AI generates the chaos. Humans organize that chaos by applying negative entropy. And then we steer the model's weights to probabilistically generate outputs that score higher, guiding it away from being random to being useful. Okay. And the last modern cybernetic example, we have to talk about model collapse, or what experts call model autophagy, or the scientific term AI inbreeding. Now, research shows that if you train an AI on synthetic data created by another AI, it gets dumb and eventually just spits out nonsense. It's like making a photocopy of a photocopy, but that reference doesn't really hold up anymore. So it's like a meme that keeps getting cropped to remove the watermark until it's completely blown out. That's a grumpy cat. So now, what happens with model collapse? It's a cybernetics problem. Humans generate negative entropy, so new information, because we interact with the real physical world. We touch grass. Whereas LLMs are closed systems. They can't experience the real world. They just remix old patterns. So when an AI feeds on its own outputs, you create a closed feedback loop. In a closed feedback loop, entropy tends to increase. So to stay smart, the AI needs a constant connection to reality or new source of information, which is us, or at least until it figures out how to get fresh data without us. That will lead nicely into dystopia. So some things we have to watch out for. Algorithmic governance. This is a project, Perspective AI. It's a project started by Google in like 2014 or so. And I like to call it automated thought policing. It scores comments on toxicity. In cybernetics, this is called a variety reducer. It suppresses signals that deviate from the norm. So the problem with this is it can often flag dialect or slang as toxic, and words constantly change the meaning over time. Sometimes words get banned to stop you from expressing an idea, or the autocorrect will guide you to using the approved words. So they made this so that things would be less toxic. So what's toxic? It's trained by people rating comments. So they'll take a whole bunch of comments they find on the internet, and then the RLHF, humans will label the data. So here, 7% similar to comments people said were toxic. I disagree with the argument. So that's 7%. I disagree with the argument. There's clearly a correlation. So 5% of people thought that was toxic because you're explaining why you disagree. And then I disagree with your argument. There's clearly a correlation. You fucking retard. 95% of people thought that was toxic. So the worry here is who decides what's toxic. This is obviously toxic. Next up is algorithmic management. Invisible boss companies like Uber. This is a cybernetic control system. You've got an app that sets the goal. The passenger provides the feedback. That's the star rating you give the driver. And the driver is just the component. If the rating drops, they get deactivated, or the deviation is correct. This is like the inverse of Project Cybersin. Cybersin gave the data to the workers so they could make decisions, whereas Uber gives the data to the algorithm to impose control. It turned the dream of the Liberty machine into a control machine. But to be fair, I think if Cybersin was allowed to carry on for long enough, it probably would have turned into a control machine anyway. We've got dead internet theory. It's the theory that the majority of the internet's no longer humans interacting with humans. It's bots interacting with bots to game the algorithms. I don't think it's a theory anymore. AI, in early 2025, AI content started to output more than humans. there's more AI content on the internet right now than human content. So you'll see this is a runaway positive feedback loop where bots talk to bots. Like on Facebook, you get those AI generated images like Shrimp Jesus. Should have seen him before. And then the bots like it. And then there's, I don't know if you've seen those ones where it's like these AI generated images of war veterans with their legs blown off, but they've got like 3 legs and then they're e-begging. But then it's just bots liking the post. I'm not sure how many real people fall for it, but the algorithm wants engagement. The bots provide engagement. The algorithm promotes the bots. And then humans get squeezed out and the internet becomes a closed system. So that's what we've got to look forward to.
Steve, I've never seen so many humans getting saved by cougar and wolf attacks by their dogs. Boomers forwarding videos to me of dogs saving their owners because of some random cougar attack. Go on Facebook or YouTube and it's literally like, just go through the shorts. And it's literally, I counted the other day, out of something like 29 videos, I'm relatively certain around 16 of those were AI generated. And it's literally just a random, like this dude in the middle of a suburb in America walking to his front door. A cougar runs out of nowhere, attacks this guy, and then the dog like jumps in and saves the dude. And there's not just one of them, there's many of them. Like it's full on. And the sad part is the number of likes. The likes, sure, the bots can do that, but the number of shares, I don't think the bots can do that.
Actually, with all the preamble out the way, I can finally get into the everyday cybernetics part. So these are personal loops or automations that you can run yourself to make your life easier. So a simple example is Google Alerts. You go to google.co.za/alerts, and then you set it up to notify you of something. So I set up a Google Alert that whenever there's something about free Steam keys, or you can make bots to enter competitions for you. But you can also use it for work. Like I'm not a stalker, but if I search for bears on Google Alerts, then whenever he posts content, he's most active on LinkedIn. In the before times, in the long ago, about 10 years ago, people would be a lot more active on Facebook. They'd be a lot more active on forums. But now it's basically, you can see if I search for Ruan, because he writes a lot of the blog posts under his own name, it's linked to his WordPress authority. So if you search for Ruan, it will come up with a bunch of the blog posts he's posted. But for me, when I was still developing on Android, I needed to use BlueStacks, which was an Android emulator you could use on PC, but it didn't work. And then the help forum had ads for Kim Kardashian's video game. So the Google alert for my name would come up with Kim Kardashian's video game. And she made 85 million off a crappy mobile game, and it made me really angry. But anyways, enough about that. Then you got APIs. APIs, it's an application programming interface. It's a set of clearly defined methods of communication between various software components. So by abstracting the underlying implementation and only exposing like the endpoints, the API reduces the cognitive load on the programmer. This is in relation to MCP servers, and these things are getting built out now. I think WordPress just released in 6.9. They've made the API endpoints a lot easier for AI to understand. So you can interact with software with the AI a lot easier. Then we've got if this, then that. It's a free web-based service. It's like make.com or Zapier or Pabbly, but it's free and you can use it in a bunch of recipes. So you can create these chains of simple conditional statements, call them applets, and then they can trigger on change of another web service, such as Gmail, Facebook, or I've seen people do things like they connect their weather service to their RGB light. So if it's raining, their lights turn blue or whatever. We can send an email message to if a user tweets using a hashtag, it will send an email. Or if you get tagged in a photo on Facebook, I don't know if people do this anymore, but then it will download that photo to your Google Drive. That's the kind of stuff you can do. Again, I just use it to find free stuff on the internet or Steam keys. I set up this thing to notify me whenever there's a free game or whatever. I can move on to prompt engineering. So I've made some tips on prompt engineering and then some examples for different job roles. So the main thing that you need to realize when you're prompt engineering is you should have these four components. This is according to the Gemini, the Google guidelines. You've got role. So who is the AI? What's its role? What's the context of the situation? What's the background to the problem or project? Task. What is the specific function that you want it to do? And format. What should the output look like? So if you follow these roles, it's going to make your prompts a bit longer, but you should think when you want to prompt the AI, you give it a little pep talk. You tell it, you're a business analyst at KPMG. I think that's what they're called. Ernst & Young. You're hot shit and you know everything about everything. Then you give it the background to the project. So you'll add your files, the brief and whatever. Tell it exactly what you want to do and then how it should output it. I want you to output it in a Google Sheet. I want you to output it as Markdown. I want you to output it as a CSV. That's one trick. So for project managers, the idea here is you're going to take your Google Meet notes and project brief and scope, and you're going to feed that into the LM to try find scope creep and blind spots, and then automatically assign which piece of the project should go. Should this go to dev? Should this go to design? Should this go to PM? What's the urgency? And then format it. I want you to output this as CSV so I can import it into Fluent Boards. Another one is the client email de-escalate. When you get a stinky email, you know that kind of email that you get when you pull the stank face, like you just smelled a dog turd? When you get that, copy paste that into Gemini with this prompt. I received a confused, angry email from a client. Read it below. Summarize the actual technical problem in one sentence, removing all the emotional noise. Then draft a response that acknowledges the issue, explains our next step, and uses a calm, professional tone. I usually tweak the emails that I get it to generate for me, depending how angry the person is. But this is a good starting point. If you're like panicking, like panic, just run this prompt, and the AI is going to take like a minute or two to generate it, so you can do some breathing exercises in the meantime. Now here for SEO, you've got contextual linking and pattern recognition in large data sets. So let's say you want to do something like we're building a silo structure for a client selling product, laser cleaning services or welding or whatever. So you give it this prompt, core entity, identify the main entity types associated with this product. Generate a list of 10 supporting article titles that link contextuality to the main product page. Half should answer informational intent, top of funnel. Half should answer commercial intent. Output. Present this as a table with columns, article title, target keyword, user intent, and internal link anchor text. So you can come up with a lot of new ideas and make sure that you're hitting the keywords and titles and target markets or target sectors very quickly before you start writing articles. You can then search the titles that you got or do a perspective check or a tone check on that content. So let's say you ask the AI, I'm writing a social media post about your topic, simulation. Act as a skeptical user on LinkedIn who loves to argue. Read my draft below and tell me, one, what is the most toxic interpretation of this post? 2, how might someone misunderstand my intent? 3, suggest a rewrite that keeps the punchiness but removes the ambiguity. And then we've got the infinite variant loop. So if you send out an email or social media post and it ends up being a banger, it gets a lot of engagement, you'll feed that into the AI, say, analyze why this worked, psychological triggers. Based on that analysis, generate 10 new variations for an A/B test that uses the same psychological principle with different wording. So if you do something and you get good results, you can use the AI to mine that idea for even more good results. And then for everyone, this is useful. If you want to make an automation and you're not sure of how you would do it, then you basically ask the AI for help. Same with when you're generating prompts. If you don't know how to do the RCTF format, you basically feed this into it and then tell it, help me write a prompt to do X using this framework. So for graphic design, this is pretty fun. So Gemini 3, Nano Banana is pretty amazing at understanding generic terms, but the more specific you are, the better it gets. I'm going to copy this prompt. Okay, so let's go to Gemini, go to Tools, create images. A high-end cosmetic bottle sitting on a piece of dark slate rock. Lighting, soft box lighting from the left with a harsh rim light on the right to highlight the glass edges. Camera, 85mm macro lens. So the aperture, shallow depth of field, all of that. Let's generate that. And then here's another thing. This is my vibe design document. I'm just going to open up another Gemini window and get that to generate while we wait. If you're making code, use Canvas. So this vibe design prompt, here's the role. You're an industry veteran, software as a service product designer. You've built high-touch UIs for FANG-style companies. So you say, you work for Apple, you know what you're doing. Your goal is to take the context below, the guidelines and the user inspiration, and turn it into a functional website. So give it inspiration, guidelines, practicalities, what tools to use, project specifications. I want soft borders. Functionality should not extend beyond what is capable of WordPress. Single landing page. So I want to create a landing page for a laser cleaning company. I want to use this image. I give it a link to the logo. I give it a link to some images, tell it what pages I want to create, and then do it. So while that's creating it, there you go. It's quite nice. So now what I'm going to do is I'm going to copy this logo and I'm going to say update the logo to this. I'm going to grab another. If you're making web or app interfaces, the more details you give it, you say like the hero section, the menu section, the hex codes for the colors and all of that. So I'm going to copy paste this, just making a Gemini window. Because it's code, I'm going to use Canvas. I'm actually shocked sometimes. Nano Banana Pro is pretty amazing. You can also do fun things like combine a whole bunch of things. I ran late with this presentation, trying to stuff it full of as many memes as I could. And I don't have enough examples of this, but you could upload like 7 different images and tell it to make a mashup. But if it makes a mistake, you just tell it you spelled that wrong, try again until it gets it right. It's also important to separate your chats into different topics. If you use the same chat for too many different things, then you could run into model collapse. And we know that's bad now. So let's see. Here we go. This is what it generated. I didn't give it the specific colors. It's just using blue, but it used the logo and it used the image I referenced. Here's a single page website. So I'll do this to get design inspiration. I'll run a couple of iterations of this, ask it what's missing, what should I add, what's confusing. I do all of that before I go to Element or Figma, just to get like an idea of what's going on. This little dashboard I made. So now the last thing I want to show you is they've introduced Gemini into Google Sheets. You get equals AI. And you give it a prompt. So this can do a bunch of stuff.
Thanks, Steve. That was really awesome.
So yeah, I ran over, but like I said, if you guys have any repetitive tasks you want to automate out of your lives, then send me a message and we can come up with a plan. If you guys learned something useful, I'll share the example prompts. I'll share the slides with you. And yeah, I can spy on your Gemini usage. I can't see your chats, but I can see how often you use the chat. Some of you don't like the AI. And I understand, I've read Revelations. It is the mark of the beast, but like, we got to make that money.
Thanks, Steve.
Yeah, thanks. That was really cool and informative. I like it.
Well, thank you for your consideration. Bye-bye, everyone.